Objectionable current is a term used in electrical engineering to describe unwanted electrical current that can flow in a circuit. It can be caused by a variety of factors. Firstly, parallel paths for returning neutral current. Secondly, improperly managed harmonics. Thirdly, ground loops. Fourthly, faulty wiring. And fifthly, improper grounding. Objectionable current can cause a number of problems, including firstly, electrical noise, secondly, equipment malfunctions, and thirdly, electrical fires. In general, objectionable current is any current that is not necessary for the proper operation of a circuit. It can be a nuisance or even a safety hazard. Some examples of objectionable current include: firstly, neutral currents that flow in parallel with the ground wire. Secondly, harmonics that are generated by electronic devices and flow back into the power system. Thirdly, ground loops that occur when multiple ground paths are present in a circuit. Fourthly, faulty wiring that allows current to leak into unintended paths. And fifthly, improper grounding that results in current flowing through the ground instead of the intended path. There are a number of ways to prevent objectionable current, including: firstly, using proper wiring techniques. Secondly, ensuring that proper grounding is in place. Thirdly, installing surge protectors and other devices to protect against electrical noise. Fourthly, avoiding the use of devices that generate excessive harmonics. And fifthly, using isolation transformers to isolate circuits from each other. By following these guidelines, one can help to prevent objectionable currents and ensure that the electrical system operates safely and efficiently. Let's delve deeper into each of these aspects. Parallel paths for returning neutral current occur when the neutral current, instead of solely returning to the source through the designated neutral conductor, finds alternative routes. This often happens when metallic conduits, water pipes, or other grounded conductive materials provide a lower impedance path than the intended neutral conductor. The presence of these parallel paths can lead to several issues. Firstly, it can cause inaccurate readings from ground fault circuit interrupters, often referred to as GFCIs, because the current returning through the ground path reduces the current differential between the hot and neutral conductors, potentially preventing the GFCI from tripping when a ground fault occurs. Secondly, the flow of current through unintended paths can induce electromagnetic interference, often referred to as EMI, affecting sensitive electronic equipment. Thirdly, it can lead to increased heating of the unintended conductive paths, potentially creating a fire hazard. To mitigate parallel neutral currents, it is crucial to ensure that the neutral conductor is properly sized and has a low impedance connection back to the source. Additionally, avoid creating unintentional ground loops by carefully planning the grounding system and minimizing the number of ground connections. Harmonics are distortions of the sinusoidal voltage and current waveforms in an alternating current, often referred to as AC, power system. These distortions are typically caused by nonlinear loads, such as electronic devices, variable frequency drives, often referred to as VFD, and switching power supplies. Harmonics can lead to a variety of problems in electrical systems. Firstly, they can cause overheating of transformers and conductors due to increased RMS current. Secondly, they can lead to inaccurate readings on metering equipment. Thirdly, they can interfere with communication systems and other sensitive electronic devices. Fourthly, they can cause resonance in the power system, leading to voltage and current amplification. To minimize the impact of harmonics, several strategies can be implemented. Firstly, harmonic filters can be installed to reduce the levels of harmonic currents and voltages. Secondly, phase-shifting transformers can be used to cancel out certain harmonics. Thirdly, reactors and capacitors can be carefully placed to reduce harmonic resonance. Fourthly, the use of harmonic generating equipment can be minimized. Ground loops occur when there are multiple ground paths between two or more pieces of equipment. This can create a loop where current can flow even in the absence of a fault. Ground loops can cause several problems. Firstly, they can introduce noise into audio and video signals, resulting in harm or distortion. Secondly, they can cause inaccurate readings on sensitive electronic equipment. Thirdly, they can create a shock hazard if a person comes into contact with 2 points in the ground loop that have different potentials. To prevent ground loops, It is important to establish a single-point grounding system where all equipment is grounded back to a common point. Isolation transformers can also be used to break ground loops by isolating the ground between two circuits. Fiber optic cables can also be used to isolate communication signals between equipment, eliminating the ground loop path. Faulty wiring can create objectionable current by allowing current to flow through unintended paths. This can occur due to damaged insulation, loose connections, or improper wiring practices. Faulty wiring can lead to several problems. Firstly, it can create a shock hazard if a person comes into contact with an energized conductor. Secondly, it can cause electrical fires due to overheating of conductors. Thirdly, it can damage equipment due to overvoltage or undervoltage conditions. To prevent faulty wiring, it is essential to use proper wiring techniques, such as using appropriately sized conductors, making secure connections, and protecting wires from damage. Regular inspections of the wiring system can help identify and correct any problems before they cause serious issues. Improper grounding can create objectionable current by allowing current to flow through the ground instead of the intended path. This can occur due to inadequate grounding conductors, improper bonding, or a lack of a proper grounding electrode system. Improper grounding can lead to several problems. Firstly, it can create a shock hazard if a person comes into contact with a grounded object that is not properly bonded. Secondly, it can cause equipment malfunctions due to voltage fluctuations or ground noise. Thirdly, it can increase the risk of electrical fires due to ground faults. To ensure proper grounding, it is important to install a grounding electrode system that meets the requirements of the National Electrical Code, often referred to as NEC. Grounding conductors must be sized appropriately and properly connected to all equipment. Bonding jumpers should be used to bond all metallic parts of the electrical system together to create a low impedance ground path. Surge protectors can help prevent objectionable current by diverting transient voltage surges to ground. These surges can be caused by lightning strikes, switching of electrical equipment, or other disturbances on the power system. Surge protectors work by providing a low impedance path to ground for the surge current, preventing it from damaging sensitive electronic equipment. It is important to install surge protectors at the service entrance and at sensitive equipment to provide comprehensive protection. Isolation transformers can prevent objectionable current by isolating two circuits from each other. This can be useful in situations where ground loops are a problem or where it is necessary to isolate sensitive equipment from noise on the power system. Isolation transformers work by providing a galvanic isolation between the primary and secondary windings, preventing current from flowing between the two circuits except through the transformer itself. Using proper wiring techniques is crucial to preventing objectionable current. This includes using appropriately sized conductors for the load, making secure and properly insulated connections, and avoiding sharp bends or kinks in the wiring. Proper wiring techniques help to ensure that current flows through the intended path and that there are no unintended current paths that could lead to objectionable current. Ensuring proper grounding is in place is another key step in preventing objectionable current. This includes installing a grounding electrode system that meets the requirements of the National Electrical Code, often referred to as NEC, bonding all metallic parts of the electrical system together to create a low impedance ground path and ensuring that all equipment is properly grounded. Proper grounding helps to provide a safe path for fault current to flow back to the source, minimizing the risk of electric shock and equipment damage. Avoiding the use of devices that generate excessive harmonics can also help to prevent objectionable current. This includes using power factor correction capacitors to reduce harmonic currents, using harmonic filters to remove harmonic currents, and choosing equipment that has low harmonic distortion. Reducing harmonic currents helps to prevent overheating of transformers and conductors, reduce noise on the power system, and improve the overall efficiency of the electrical system. By implementing these strategies, one can significantly reduce the risk of objectionable current and ensure the safe and efficient operation of electrical systems. Understanding the causes and effects of objectionable current is essential for electrical engineers, electricians, and anyone involved in the design, installation, and maintenance of electrical systems. It is important to follow best practices and adhere to the requirements of the National Electrical Code, often referred to as NEC, to minimize the risk of objectionable current and ensure the safety and reliability of electrical systems. In summary, objectionable current is an undesirable phenomenon in electrical systems that can lead to various problems, including electrical noise, equipment malfunctions, and electrical fires. It can be caused by factors such as parallel paths for neutral current, improperly managed harmonics, ground loops, faulty wiring, and improper grounding. Prevention strategies include proper wiring techniques, ensuring proper grounding, installing surge protectors, avoiding devices that generate excessive harmonics, and using isolation transformers. By understanding the causes and implementing preventive measures, one can mitigate the risks associated with objectionable current and maintain the safety and efficiency of electrical systems. The topic of objectionable current is not always straightforward, and it often requires a comprehensive understanding of electrical theory and practical experience. If you encounter objectionable current issues in your electrical system, it is advisable to consult with a qualified electrical professional who can diagnose the problem and recommend appropriate solutions. Remember that electrical safety should always be the top priority when dealing with electrical systems. Always follow safety precautions and consult with qualified professionals when necessary. Regular inspections and maintenance can help identify and address potential issues before they become serious problems. Staying informed about the latest electrical codes and standards is also important for ensuring the safety and compliance of electrical systems. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional for any electrical work or troubleshooting. It is also important to note that the specific requirements and recommendations for preventing objectionable current may vary depending on the application and the local electrical codes. Always refer to the applicable codes and standards for guidance. Understanding the principles of grounding and bonding is crucial for preventing objectionable current. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metallic parts of the electrical system are at the same potential. A properly designed and installed grounding and bonding system is essential for minimizing the risk of electric shock and equipment damage. Harmonics can be a complex topic, and it is important to understand the different types of harmonics and their effects on electrical systems. Harmonic analysis can be used to identify the sources of harmonics and to determine the appropriate mitigation strategies. Mitigation strategies may include the use of harmonic filters, phase-shifting transformers, or other techniques. Surge protection is an important aspect of protecting electrical equipment from transient voltage surges. Surge protectors should be installed at the service entrance and at sensitive equipment to provide comprehensive protection. It is important to choose surge protectors that are appropriate for the application and that meet the applicable standards. Isolation transformers can be used to isolate circuits from each other, which can be useful in situations where ground loops are a problem or where it is necessary to isolate sensitive equipment from noise in the power system. Isolation transformers provide a galvanic isolation between the primary and secondary windings, preventing current from flowing between the two circuits except through the transformer itself. Proper wiring techniques are essential for preventing objectionable current. This includes using appropriately sized conductors for the load, making secure and properly insulated connections, and avoiding sharp bends or kinks in the wiring. Proper wiring techniques help to ensure that current flows through the intended path and that there are no unintended current paths that could lead to objectionable current. In addition to the above, it is also important to consider the impact of objectionable current on sensitive electronic equipment. Objectionable current can cause noise and interference that can disrupt the operation of sensitive equipment. In some cases, it may be necessary to use special grounding techniques or filtering to minimize the impact of objectionable current on sensitive equipment. Finally, it is important to remember that electrical systems are dynamic and that conditions can change over time. Regular inspections and maintenance can help identify and address potential problems before they become serious issues. Staying informed about the latest electrical codes and standards is also important for ensuring the safety and compliance of electrical systems. The prevention of objectionable current is an ongoing process that requires vigilance and attention to detail. By understanding the causes and implementing preventive measures, one can significantly reduce the risk of objectionable current and ensure the safe and efficient operation of electrical systems. It is important to consult with qualified electrical professionals for any electrical work or troubleshooting. They have the expertise and experience to diagnose problems and recommend appropriate solutions. Remember that electrical safety is always the top priority.